This is experiment 43 called Fischer esterification. The first thing we're going to do is get the reaction started with a reflux apparatus. I have all the chemicals pre-measured and pre-weighed. So we're going to start the distillation process. First, we're going to add a quantity of benzoic acid into the flask. It's a good idea to add the dry powder first. If you add the liquid methanol, you'll get powder caught on the edges. So add the measured quantity of methanol, and then half a milliliter from a micro syringe of concentrated sulfuric acid. And then, since we're doing considerable boiling, we want to add a couple of boiling chips to make it a nice steady boiling. Set our heating mantle to around 6. Put the material mixture into the heating mantle. Now with a reflux apparatus, we're going to do countercurrent flow through the apparatus. So the water comes in the bottom and goes out the top and cools everything else. And any vapors that come up from the reaction will come up through here and be released. So we now have nice water flow in and out. We have the mixture in the distilling flask, and we just wait for the heat to start the mixture boiling. And we have 1 hour to wait after reflux starts. Reflux is simply as the liquid vapors come up, they hit the cool water jacket and they condense back down and go back into the mix, and essentially causes the reaction to take place. Okay, so it's only been in the mantle for a few minutes. You'll note that the mixture is boiling and it's already vaporizing, and as the vapors condense in here, they drop back down back into the liquid to assist with the reaction. And that's the Fischer esterification part. So at this point, I would start my 1 hour timer and let the reaction go for 1 hour and stop it after 1 hour. So our hour of reflux is complete. The system has been reacting. We're going to cut the heat. We can leave the flow of water on, but we'll just remove the condensing flask. It's still pretty hot. I can still hold it here though. We're going to let it sit in there for a couple of minutes, and then we're going to put it in an ice bath. In the meantime, I'm going to go through the flow chart And much of that flow chart I'm going to do, but just look at the flow chart and keep in mind that's what I'm going to do. This is experiment 43, which is Fischer esterification. Anytime you take an organic acid, you react it with an alcohol, you're going to get an ester and water. In this case, we took benzoic acid. We're reacting it with the simplest alcohol that we have, methanol, adding a little bit of concentrated sulfuric acid and undergoing reflux for an hour. We're producing the ester methyl benzoate. The data that we need, and I'll write all this data in later, and you can make the appropriate calculations. We're going to need the mass of benzoic acid that we initially took, the final mass of unreacted benzoic acid, which we haven't gotten yet. Then we're going to need the mass of an empty beaker and the mass of the empty beaker plus the ester, which we haven't gotten yet. We have to go through an extraction process. And then you determine the mass of the ester. So everything is based on mass for this experiment. This is a KEQ, or an equilibrium constant, which we can't do anything with at this point until we get all the data. But that's how you make the calculation. The best way to describe this experiment is through a flow chart. It's easier to see step by step what has to be done. It might look a little busy, but if you follow the sequential order, it's pretty straightforward. We took the 3 components into the distillation vessel, the distilling vessel, and we refluxed for 1 hour. We're finished with the reflux, and we're going to go through these series of steps to prepare the solution for extraction. Cool it in ice water, add layers, add water until you get 2 layers, add methylene chloride, CH2Cl2, and then we're going to transfer it to a separatory funnel. So I'm not going to actually show you those step by step, but I will do it in this order. Once we get the separatory funnel set up, we're going to have 2 layers. The top layer is going to be aqueous. The bottom layer is going to be organic or methylene chloride. The ester that we're going to obtain at the end will be in the organic layer. The benzoic acid that doesn't react that we're going to get at the end is going to be in the water layer. So we're going to go back and forth several times. Leave it in the separatory funnel. The bottom layer is methylene chloride. We drain it into a small beaker. We come over to the other side. We'll have the top layer of water, and then we're going to add more methylene chloride and perform another extraction. And then separation of layers once again. The lower layer is going to go back into the small beaker that we have on the left side of the flow chart. The top layer is going to contain the aqueous layer or unreacted benzoic acid. We'll go to this side first and then we'll transfer to that side. So now we're ready to take the water layer, drain it into a small beaker, and the water layer that we're going to obtain from the left side is going to go into that small beaker, and then we can go through the process of obtaining benzoic acid that's not reacted. Precipitate the unreacted benzoic acid by adding hydrochloric acid, test it with pH paper, cool in ice, suction filter, dry it below 100 degrees, and then weigh the amount of benzoic acid collected, which is unreacted. That'll take care of the right side of the flow chart. Now if we go back to the left side, You'll have all your methylene chloride layers on the left side. Return all lower layers to the separatory funnel and extract with sodium bicarbonate. Sodium bicarbonate will be an aqueous layer, and once again the lower layer will be methylene chloride, which will contain the ester, and the top layer will contain water. And again, I indicated that that comes back to the right side, and we'll go through the extraction. Once we have the lower layer, we drain it into a small beaker, add 1/2 gram of magnesium sulfate, which we're going to set aside. Magnesium sulfate is a drying agent, and it'll pull out any moisture from the methylene chloride that's in the beaker. Then we'll decant it. Decant it simply means pouring off the top layer. Don't want to get the magnesium sulfate, leave that behind, into a 50 ml beaker and get the tare weight. And then evaporate the methylene chloride. And keep in mind the methylene chloride or the ester that's formed is going to be a liquid in methylene chloride. We're going to evaporate the methylene chloride and then weigh the ester, and that'll be our final determination. Okay, we have the reaction mixture into the separatory funnel with the methylene chloride, and now we have to do an extraction. And you've probably done extractions before, but you don't want to do it too vigorously, and you want to make sure you vent it, because you have an organic and you have water, and we want to get everything that's in the water phase into the organic phase. So we do this for about a minute. Not too vigorously. Shake, invert, and vent, because you're going to build up pressure. Shake, invert, vent. Just don't forget to close the valve after you vent. And we're going to left with 2 layers. Top layer is the water. The bottom layer is the methylene chloride. Okay, so we did that for about a minute. Let the layers separate a bit. You have pretty good separation. We're just going to leave it in here, let it settle out. And you can note the 2 distinct layers. Once again, the top layer is aqueous, the bottom layer is the solvent. So now we're going to go through the flow chart. We're at step 1. This layer contains the ester, This layer contains the unreacted benzoic acid. So now we're going to go to step 2. We're going to add more methylene chloride to the separatory funnel. And we're going to do another extraction. Rotate, invert, vent. Rotate, invert, vent. %90 of the ester will come out with the first extraction, and roughly another 9%, 9.5% will come out for the second extraction. Okay, that's pretty good. Let it settle as we did previously. So we're continuing with the extraction. This is the second extraction, step 2 in the flow chart. The bottom layer has the methylene chloride. We want to put that into the same original vessel that we had with the first extraction. Top layer contains the unreacted benzoic acid. And we're going to go now to the left side. We've gone 1, 2, 3, 4. Now we're going to put this into another beaker. This is the top layer. Right side of the flow chart, left side of the flow chart. Now we're at step 5 on the flow chart. We're going to put all the methylene chloride extracts back into the separatory funnel. We got rid of the aqueous. And we're going to add saturated sodium bicarbonate and do another extraction. Shake, invert, vent. You notice there's more pressure building up because of the sodium bicarbonate. Shake, invert, vent. Now you'll notice another separation of the layer. The bottom layer is the methylene chloride, and the top layer is the aqueous again, the water. We're going to let this settle for a couple of minutes. This is the final extraction. Again, the methylene chloride layer in the bottom. So we're going to transfer that to another beaker. And now we're left with the aqueous on top, which we're going to go back over to the other side of the flow chart and add the top layer to the other top layer. Now we have the left side of the flow chart, which contains the ester, and the right side of the flow chart, which contains the unreacted sodium benzoate or benzoic acid. Okay, now we're in step 6 of the flow chart on the left side to complete the obtaining the ester. And I know you don't notice the odor, but it's a minty smell. And typically methyl benzoate has a smells like mints. We're going to add magnesium sulfate, which is a drying agent, just all of it. It won't dissolve, it just picks up moisture. And when you do the final step, you want to get rid of all the moisture that you can. So now we have to wait for 10 minutes on that. But in the meantime, we can go to the right side, add a little bit of concentrated hydrochloric. Now we're at step 7. You may not even need it. I'm going to add 1 drop. Two drops. We're going to check the pH to make sure it's acidic. If not, we'll add a little more hydrochloric acid. Deep maroon, that's definitely acid, so we don't have to do anything more to that sample. We just have to cool it in ice. Okay, so we've got our methylene chloride mix in magnesium sulfate, which is drying it. It's pulling all the moisture out. Now we're going to decant into a beaker that I've weighed. And if we were successful in getting rid of the moisture, you don't want to get the sulfate in there, then this should be evaporating, and it's a liquid. That's the ester, methyl benzoate. We're going to let it boil. Once the bubbling stops or slows down considerably, that's the amount of ester that's remaining, and we're going to weigh it, and that's what we'll report. This is the right side of the flow chart on step 7. We have unreacted benzoic acid, and we're going to filter it through a suction filtration apparatus. And I've weighed the filtering, the to the filter paper, so we can go by difference. We don't have to figure out anything after we filter it. Turn on our vacuum, put a little bit of water. We have a measure of the dry. And then we're going to go there is some unreacted benzoic acid because not all of it reacts. So we got most of that out of there. We'll just let the suction filtration do its job, and we may not even have to dry it in the oven. We'll just take the value from the filter paper. Okay, we completed the experiment, and I'm going to insert all the data that you'll need to make your calculations and to write your formal report. The initial mass of benzoic acid, 4.1 grams. We'll come back up here. The mass of the filter paper, 0.2284 grams. The mass of the unreacted benzoic acid plus the filter paper, benzoic acid, you can calculate the mass of the unreacted benzoic and after the subtraction, and then put that value up here, mass of unreacted benzoic acid. It's a small number because most of the benzoic acid reacted to produce the ester. And finally, the mass of the ester, the empty beaker, the mass of the empty beaker, the beaker plus the ester, and you can calculate the mass of the ester by difference. Once you get these figures, or these numbers, calculate your equilibrium constant. Just follow this procedure, and you can use the quantities that you convert from mass to moles. You have all the molecular weights.